I'm back with another exclusive project, and this time we are going to deal with hospital patient flow and bed occupancy analysis. This is a portfolio ready project just like the last one, but this is something better because in this project we are going to work with the tools like Azure Data Factory, Synapse, while following the enterprise best practices like Medallion storage structure and designing Star Schema while dealing with slowly changing dimensions and schema evolution. What makes this project special is this is not just theory. We are going to work on this project practically from scratch, starting from the raw data, building a data pipeline, automating the workflows, and making the pipeline work without any human intervention. And here's the best part. If you're looking for a best portfolio project to showcase your data engineering skills, stick around, build this project yourself, add it right into your portfolio. And with that being said, let's dive in. Let's begin with understanding the client requirements and the final deliverables of the project. I asked ChatGPT to create a fake client and the requirements, and I got this file. It created a fake client named Midwest Health Alliance, and the subject is development of real-time data platform for patient flow and bed occupancy analytics. And our client also have a background. It says our client has 7 hospitals across Midwest region, and they're struggling to monitor bed occupancy, patient admission, discharge patterns, and department loads, which we are going to solve in this project. And the business objectives are monitoring patient admissions to minimize waiting times and identifying department level bottlenecks. It is basically knowing which department has high load and which doesn't, and enable gender-based and age-based KPIs, which we will be dealing with at our data analytics part, and automate alerts in case of failures. In case the data pipeline fails, we need to alert the person who manages the pipeline so we can fix it and make it work again. And the functional requirements, data source. The data source, we will be generating the data with the simulator code that produces the data with patient admission, discharge time, and the patient demographics too. And we have for the data processing and storage. For the storage, we are going to use Medallion Architecture. This is a widely used architecture with 3 layers of storage: bronze, silver, and gold. And we are going to handle schema evolution. Schema evolution is nothing but if the schema of the data set updates, it shouldn't break the data pipeline. The data pipeline should adapt to the new schema. So that is what handling the schema evolution means. We will be handling schema evolution at the data processing stage. And implementing SCD2, slowly changing dimensions. This deals with the dimension that changes over time. Like for an example, like a patient age, which changes every year. So we're going to update the patient age and also keep the old record with the old age, and change the status as inactive for the old one and active for the new one. Implementing Star Schema. Star Schema is a storage method where we're not going to store data. Instead of storing the data in just one table, we're going to divide them, split them into few dimension tables and a fact table to connect these dimension tables. In our case, our generated data will have these columns in our data. So we can split these columns. Let's say just 3 columns, just these 3 columns in patient dimension table, and hospital ID and bed ID into, let's say, department dimension table. These two are the dimension tables, which patient dimension stores the demographics of the patient, and department dimension stores the hospital information. And for connecting and storing the transactions that are done, another table, which is the fact table, is created to connect these both dimension tables, which includes the SOR gate key. We're going to assign a SOR gate key for all the records that are in patient dimension, which is the unique ID to identify every single record. We'll assign it to patient dimension table and also department, and so that we can connect to these two dimension tables from fact table using those SOR gate keys. Let's say SOR gate patient, SOR gate department, with these two keys, and the rest columns will be admission and discharge. So we're going to create three tables, one for the patient demographics, and the other one for the hospital information, and the fact table to store the transactional data. This is basically the Star Schema. Save. In the analytics part, we're going to use Synapse as our data warehouse. And orchestration and automation, we will be using Data Factory for that, and data quality. Unlike our last project, we're going to include some dirty data in the data source this time. And security and compliance, role-based access control. And these are the important deliverables at the end of this project. We need to create a fully functional Azure-based data pipeline, Power BI dashboard connected to live Synapse queries, data quality and validation reports, full project documentation with architecture, data models, Git repo. So this is the client requirements, and let's now head to the architecture of the project. This is the name of our project, Patient Flow and Bed Occupancy Analytics. It starts with the data source, of course. We will be using a simulation code to generate the data, and then the generated data will be streamed on Event Hub as platform and Kafka as streaming engine. And this is the data streaming stage. And now head to data processing stage. The data will be taken out from Kafka and ingested into bronze table, just the raw data. And then this raw data will be pulled out and cleaned and will be ingested into cleaned data, which is silver tier. And then this clean data will be pulled out, transformed, and then ingested into gold tier, which is the business ready data. So this whole data processing stage will be done in Databricks. And we will be using Data Factory to automate the transition between silver and gold. We will know more when we come to that part. And after that, the business ready data will be referred with the SQL Pool in Synapse, which is our data warehouse, and then it is connected to Power BI, and we can create the dashboard in Power BI at the end. We are also going to use Key Vault so that we don't expose the connection strings and the access keys for the storage accounts. So we save them, we store them in the secrets inside the Key Vault, and we access them from there. So we don't expose the connection string. And then we use Azure Active Directory to give access to the Key Vault. So that's the basic flow of the project. Now let's head to the simulation code that we have. I asked ChatGPT to create a simulation code, and this is what I got. Okay, let's understand what we have here. These are basically the modules that we imported in this code: JSON, random, datetime, UUID, and this whole thing is a configuration to connect to Event Hub. And then we created a list of department names, and we created a list for genders. and we have a function named ingest dirty data. Before explaining this function, we need to know this one. This is the main function, generate patient event, where the actual patient events got generated. Here we have a variable named admission time, which is equals to datetime.utc_now, which retrieves the current time, and that time will be subtracted with the time delta of hours equals random.randint. This method, random.randint, is used to pick a random integer in the range of 0 to 72. So and that will be converted into an actual time hours, and if the output of this rand.randint is 50, that 50 hours will be subtracted from the present time and it will be given to the admission time. Just to make it more realistic, not all admission times have present time, right? Some will be in the past, so we're going to create some past admission times too. But the admission time can be past or present, but it cannot be in future. We'll be doing discharge time equals admission time, which we created before, plus the same function, time delta hours equals random.randint of 1 to 72, just to add a few hours to the admission time to get the discharge time. And this is the event. We created a dictionary here. Our first column, patient ID, is created using uuid.uuid4. This method is used to get a unique ID for every record, and we use gender random.choice. Random.choice is a method used to pick a random object from a given list. So here we give genders as the list which we created, so it picks a random objects from them. Either it can be male or female. And then we have age, which is random integer from 1 to 90. Let's say 100. 1 to 100. And department, random.choice of departments. Like I said, it picks a random object from the department list here. And we have admission time.iso format. We are defining the format of the time. And discharge time ISO format. Bed ID is random integer between 1 to 500. And hospital ID is a random integer from 1 to 7, because our client has 7 branches. And return the outcome to ingest dirty data. Now it goes to this function. This function is actually here to ingest dirty data, and the chance of this dirty data to get ingested into the record is 5%. To make sure it is 5%, we use this method. Random.random of creates a random decimal from 0 to 1, and if that decimal is less than 0.05, then this will execute. And this is the way of ingesting dirty data into it. Record of age equals random.randint of 110 to 150. Let's say 100 to say, or 101 to 150. So a random age from 101 to 150, which is dirty data. And then we do the same here, and here we do record of admission equals datetime.utc_now, the present time, plus hours random.randint, a few hours. So you're going to add a few hours to the present time and assign it to admission time, which will be the dirty data too, because admission time can be in past or present, it cannot be in future. So we do that, and this is a loop. We use while true to create an infinite loop. It executes until we interrupt it. And event is a variable assigned to the record that is generated by the generate patient event. And producer.send of event hub name, we'll be replacing this with the event hub name here. and it will be given the event, and then the record that is sent to the event hub will also be printed for us to refer, sent to event hub as static string, and the event that is sent will be displayed here. We use f strings for that. And this method time.sleep of 1 is a method we use to make the loop delayed. If the loop executes once, it delays for a second before it executes the loop again. So in that way, we create 1 record per every second, which means 60 records per 1 minute. So this is the generator code. Now we have this. Now because we have this, now we also need Event Hub to stream this data. So let's go ahead, open Azure. If you don't have an Azure account, Azure offers a free trial for 12 months for any new user, and also they offer $200 worth of free credit which expires in 30 days. If you haven't had to have an Azure account, go to the browser and click for Azure free trial. Click on this. You need to enter your basic information like name, email ID, and it asks for your card details, but Azure won't charge you without you acknowledging that. So it just takes your card information for security and it won't charge you. And this is the portal you create the account. After you create the Azure account, you'll be landed in this home page right here. And on the left pane, if you click these 3 lines and click on cost management, you'll see any billing that happened on your account in this page. Right now I have 12,000 rupees worth of free credits that I can use. I already used 4,000 rupees. Let's head back to home. Now click on the search bar at the top, search for Event Hub. Create. Choose your subscription name. Mine is Azure Subscription 1. And for the resource group, we have to create one. We never created one. So hit on create new resource group. Name it RG Hospital Analytics. Create. And the namespace name Hospital Analytics namespace. And for the region, choose your closest region. Mine is Central India. Pricing tier standard. Throughput is the bandwidth that you will be offered by the Event Hub. If you choose one throughput unit, it is equivalent to 1 ingress, 1 megabyte per second ingress, and 2 megabyte per second egress. Ingress means incoming data, and egress stands for outgoing data. And enable auto inflate, if you activate it, the throughputs inflates automatically if the threshold is not enough for the incoming or outgoing data. In our case, I'll just choose 1. It is more than enough, and I'm going to uncheck the auto inflate. And that's it. Hit review plus create. Hit create. It just takes a few seconds to deploy. Now our namespace is created. Let's go and create the actual Event Hub. Now when you click go to resource, you have to click the Event Hub that is on the overview page right here. You create the name Event Hub, name it Hospital Analytics EH. Partition count 1, cleanup policy delete, retention time, let it be 1 hour. That is the time that the Event Hub holds your data on stream before it gets deleted. So we are getting 1 hour. If you choose 1, we get 1 hour. Before this 1 hour expires, we need to pull the data out of the stream and store it somewhere in the storage account. Review plus create. Create. Now the event hub is created. Let's go and this is in text format. Now I need to store it in .py, the Python file format. I'm going to copy that into a new notebook. Save as. Save it in C drive, users folder, your username, and here name it, let's name it patient flow generator. At the end, you need to specify .py to make it a Python file. And save as type should be all files, and encoding should be UTF-8. Then hit save. This already exists. I'm going to replace it. And now, here we can fill the namespace hostname and hub and namespace connection string in the configuration. We just need to configure this and run it right away. So firstly, we need namespace hostname. For that, we head to the namespace overview panel right here. You can see hostname right here. You need to copy the hostname, paste it here, and for the event hub name, scroll down to the bottom in the overview panel. You can see the event hub name right here at the bottom. Copy that, paste that in the event hub space, and we need the connection string to connect to the namespace. For that, on the left pane, click on settings, click on shared access policy, root manage shared access key, and copy the primary connection string. Click the copy button and paste it here in the connection string section right here. Now hit Ctrl S to save the file, and let's see if it works. Open start menu, search for any command prompt, any prompt. I'm going to use Anaconda prompt. You can use command prompt as well. See, we stored our .py file in this location. Before running the file, you need to make sure your system is installed with Python and also Kafka. After you install Python, hit pip install Kafka -Python to install Kafka. If you already installed, it says requirement already satisfied. Mine is already installed. And after that, you need to click Python and our file name, patient flow generator.py. Now it connects to the event hub and pushes the data into it right here. If we take a look at it, it says this is the status string we defined in the print using f strings, and this is the actual record that we are pushing it into the event hub. We have patient ID, which is a random unique ID, and the gender, age, department, admission time, discharge time, bed ID, hospital ID. If everything goes fine without any errors, you will be seeing this data streaming on Event Hub namespace right here in the overview panel. This chart rises. It takes few seconds to refresh, but it will change. Now here we can see in the overview panel right here, the chart, the spike rises up, showing it already got 40 records that we generated, and it is there on the stream now. So this confirms our data is getting ingested into Event Hub. Now, now we know the code is working. Let's just create a Git local Git repository and add the code into our Git. For that, we need git bash. This is just git CLI. If you don't have git bash, just go to browser and click git bash download, and the direct link to download is right here. You can click download and install it. And let's head back to git bash now and create some files. I'm going to create a directory. To create a directory, we use mkdir, which stands for make directory, mkdir, and the directory name as hospital patient flow analytics. Hit enter. Now this directory should be created at the destination. C users username right here. This is the directory that we created. Right now it is empty. Now we're going to initialize Git inside that directory. To do that, you run git init and hit enter. Initialized empty Git repository. Now let's go hospital patient flow. Wait. I did a mistake here. We shouldn't initialize the Git unless we run this command. We need to do cd, which stands for change directory, and copy paste our directory name and then run. Now it is in that directory. Now we need to initialize Git inside the directory. Git init initialized empty Git repository. Now we should be able to see .git file inside the directory. Now head back to git bash. Let's create an empty readme file for the GitHub. For that, we need to type in touch. Should say echo. Let's just put a string inside the readme. Hospital patient flow analytics. Let's say that, and greater than symbol to assign it to readme.md. This creates a readme file inside the repository with the string that we specified. Okay, that is done. Now let's go create a few more folders inside it. We use mkdir. We need Databricks notebooks. We need a folder to store the Databricks notebooks, and we also need a folder to store the simulator code, which is our producer code. And we also need a folder to save SQL Pool queries. Say SQL Pool queries. And we also need a folder to store the Power BI workbook. Power BI. Now hit enter. Now these folders will be created inside the directory. And now do git add all. Git add dot means we are adding everything that we did till now into the Git. And we need to commit now. We do we need to run git commit to commit the changes that we did with a message. -m is a flag that used to define the message. Message initial git structure. Structure setup. One file changed and that is added. So we committed the changes now. Now let's push this into the actual GitHub, which is the website UI. For that, we need to open your Git bash. This is my Git bash, GitHub. Now create a new repository. Let's name it same as my directory. Hospital patient flow analytics. Let's name it the same. And hit create repository. Now we have the repository. To push the commits that we did to the Git repository, we need to run git remote add origin, and we need to copy the link for our repository in here, paste it. Paste it, hit enter. No. Let me do that again. I forgot to include .git at the end. Origin. Now paste the link. At the end of the link, we need to include .git. It says remote origin already exists. In order to remove it, we type git remote rm, which stands for remove origin, to remove the existing origin. Now we create the origin that we need. Copy, paste. Now it is created. Now the origin is created. Let's confirm it with this command. There it is. Our origin is successfully created. That confirms it. And now do git branch. Find the branch as main. Git branch main. Now the master switches to main. Now here, let's push our our commits. Git push -u origin main. If you're doing this for the first time, your GitHub asks for to log in again. You need to put in your credentials and log in again. But I've did it several times, so it never asked me. Now I head to GitHub again. I need to refresh the page. I should be able to see the commits that I did. Commit history. There is just one commit history, which is initial git structure. Oh, I spelled it wrong. That's fine. So that is the commit that we did. We only did one commit now. Now let's also push the code that we ran, the simulation code that we already have. But GitHub doesn't accept any personal credentials like connection strings or connection keys or passwords should be in the file. So they should be taken out first and then pushed into GitHub. For that, let's copy this. Now, let's just copy the simulator code that doesn't have any credentials. Copy, save as, save it inside our local Git repository inside the simulator code. Name it patient flow generator, .py, and files, all files, utc8, save. Now open Git Bash. Here click CD, type CD, and the folder name is simulator. We're inside the simulator now. Now add git add and our file name, which is patient flow generator, patient flow generator .py. Git commit with a message saying simulator initial simulator code. One file changed. Now push that again using Git Push, copy, paste. Now it is added. Now we need to refresh this and we will be able to see the code. This is our code. Well, I mainly use GitHub for version control. In case you wonder what is version control, I'm going to show you an example now. Let's say this is my generator code. Let me add another line underneath, maybe 2 lines, one empty line, and I'm going to add another line saying example, just example, and save it. Now add that to Git again. I'm going to copy paste it. Git add patient flow, copy, paste, and commit that. Git commit. I'm going to commit that with example as message. One file changed, and now push that again into GitHub. Now it is added. Now, in case if you wonder what is version control is, if you refresh the page, if you go back to our code, click on the code, we see the history button here. If you click it, there you can see 2 versions of our code. One is the initial one without the line that says hash example. The other one is the new one with the line, and it shows how many lines are added, 1 empty line and 1 hash example line. And how many lines are taken out? 0. I never took out any lines, so it says 0. So this is basically if you are working on a code or a file and you don't want to you don't like the new version of it, you want to go back in time and work with the old version, you can go back in time anytime you want. That's why we use Git. I use Git basically for the version control. So the old code is also here without the extra line that says hash example at the end. So that is how basically version control works in GitHub. Now let's just close this GitHub. Now we have the records that are getting streamed on Event Hub. Okay, let's head back to the architecture first. Our architecture. We're done with these 2 stages. We created the data source, we streamed the data on Event Hubs, and now we need to pull out the data and we head to data processing stage. Before heading to data processing stage, we need two tools in that. We need a storage account to store the data. We need Databricks to process the data. Now let's create Databricks first. Head to search and search for Databricks. I clicked the wrong one. Azure Databricks. Hit create. Now choose the resource group that we already created, and workspace name, let it be Hospital Analytics Databricks. Region, your region that you specified when creating event hubs. And the pricing tier, let's go with trial premium 14, that has all the features in it. And for the manage group, let me just copy this and name it MRG Hospital Analytics Databricks. And that's it. Let's hit create. Unlike the event hubs, Databricks takes much longer to get deployed. So until it is in the deployment stage, let's open a new tab, open Azure again, login. Let's create the storage account in the meantime. Go to search and search for storage account. Now create a storage account, the same resource group that we created, and for the storage account name it hospital storage. Let's name it hospital storage. And by the way, the storage names doesn't take any hyphens or underscores. It should be strings and numbers, the combination of strings and numbers, that's it. Region should be Central India. Primary, I'll leave it as is. And performance standard. Redundancy, I'll choose local. Redundancy is about security. When I say security, it doesn't mean the literal security meaning. I mean the risk of losing your data that is in the storage depends on this. If you choose LRS is the less secure option, there is a chance of losing your data. But when you go down in these options, it gets more secure. Your data get more secured. In my case, it's just a personal project, so I'm going to choose LRS here and hit next. We need to enable hierarchical namespace and then hit review plus create. And then create. Let's check on the Databricks. It is still in progress. And now the storage account is also in progress. Let's just wait a few seconds. Well, our storage account is deployed now. Let's go ahead and click on go to resource. This is the page, this is the landing page. We need 3 containers because we are using Medallion storage structure, which has 3-layer storage, bronze, silver, and gold. So we need 3 containers. For that, on the left pane, click on data storage, click on containers. Here, click add container. First, let's add bronze container, bronze, and silver, and followed by gold. We also need one more container for initializing Synapse. So let's create another container for Synapse. Let's say Synapse workspace. So we have 3 containers for the storage and 1 for the Synapse. That is all set. Now our Databricks also is deployed. Let's close this extra tab. Hit go to resource on Databricks, launch workspace. It opens in a new tab and you also need to log in again. Here, before creating a notebook and coding in that notebook, we need a cluster to work on with. So on the left pane, click compute and then click on create compute. Here, name your cluster. I'm going to name mine as hospital cluster, policy unrestricted. I personally check out these two options, machine learning and photon acceleration. They charge you extra. And I'm going to leave the version as default. And for the worker type, I'm going to choose the lowest one possible. The lowest one is standard F4 and standard F4S. Here, in case you don't know what a worker is, basically the Databricks cluster works on Databricks units, which are the combination of drivers and workers. The drivers are usually one, but the workers vary from the range of, I think it is infinite. You can have infinite number of workers. And each worker specifications will be specified in this worker type. It depends on how fast you want your data to be processed. In my case, I've chosen the slowest machine, which offers 8 gigabytes of memory and 4 cores. There is also a lot of machines. One machine even has 512 gigabytes of memory and 64 cores, which is the fastest machine, I guess, probably. Yeah. So that is the worker type, and depending on how many workers you choose here, minimum and maximum, the driver splits the work between the workers to make it faster, which is the parallel node processing. Any task that you give to the driver, it splits up between the workers and process that job parallelly and make it faster. So in my case, I don't want it to be so fast. I'm going to go with single node. And the terminate after, I usually do 10 minutes. That's more than enough. And I'll leave the other options, the rest of the options as is, and hit create. Just like the Databricks workspace, cluster also takes too long to create and start. While the cluster is still processing, let's go and create the bronze transformation code. Let's go back. It is still processing. Now on the left plane, click on new, click on notebook, a new notebook, rename it with saying 01, which is our first step in the data processing. Say bronze raw data. Here, to begin with, we're not going to do any of the cleaning or any of the processing here. We're just going to take the data out from the stream and we're going to convert that from binary into JSON strings and load it into bronze table. Why we get binary means any data that is streamed using Kafka is converted into binary data. So if we want to use the data again, we need to convert it into string and then we store it. So let's just import the modules that we need here. We need from PySpark dot SQL dot functions import all modules from functions library, and we need to configure to the event hub first. And I stored my configuration settings here in the requirements, ADLS configuration, store the configuration settings here. We need these configurations to connect to the event hubs. It's just a default configuration. And let's fill this later, but first let's design our code first. So we got the connection to the event hub. If we got the connection to the event hub, we need to read the stream from the event hub and store it somewhere in the variable here. So let's create a variable named raw_df equals bracket spark dot read stream dot format of Kafka dot options asterisk Kafka options. Dot load of. Well, here Kafka options is a dictionary that we created in Python, where we need to pass this configuration dictionary basically into the options with the format options. So to convert it from dictionary to options format, we use double asterisk at the front. That's what we did here. And we're defining the format is Kafka. We're getting the data in the format of Kafka. And dot load to load the data. And now, let me just name it first. Read from event hub. It's just a heading. So we now read data from the event hub stream. Now we need to convert it, which means we need to cast data to JSON strings. In order to do that, let's just say JSON df equals raw_df dot select expression expr cast of value as string as raw JSON. This is the expression that we use to convert the binary data into a raw JSON string. Now we have the raw JSON string. All we need to do is store this JSON file into our bronze table. In order to do that, first we need to get permission to do that, access to the storage account. So to get that access, we need to define the configuration here. Have the configuration as well. Right here, need to copy paste it. This is basically the configuration that is used when you want to connect to an ADLS2, which is Azure Data Lake Storage 2. This is the configuration for that. Now we have the configuration. Now we need to specify the path to write the data. So for that, we are going to create a variable named bronze path equals, and for the syntax for the path is this right here. We specify the path here and assign it to the variable bronze path. This should be in quotes. And now we define the path, and we have the configuration, we have the connection to the storage account. Now we need to write the stream. For that, let's just name it write stream to storage to bronze. Say JSON df dot write stream. Format is delta. Output mode, we have a few output modes. Includes append and overwrite. Append just appends the new record at the bottom of the dataset. So we're going to do that here. Output mode should be append. And we need a checkpoint. We need a checkpoint to store the checkpoints folder to store all the checkpoints when we run the stream. Checkpoint location. Say dbfs mnt bronze underscore checkpoints patient flow dot start of bronze path. Now we also define the write stream here. We use option checkpoint to create a folder named checkpoint, and inside that a folder named patient flow to store all the checkpoints to know where the stream is stopped. Let's say we ran the code, it just loops and loops again until the stream pushes until the data is getting pushed into the stream. If the system got shut down or it has a breakdown and stops in the middle, and we need to fix it, and we need to rerun this code again. When we rerun the code, we don't want the code to read the past data and do process the past data again. So we use checkpoints to checkpoint the data that is already processed. So whenever the system restarts, it won't start from the beginning, it starts from the checkpoint where it stopped. So that's why we use checkpoint when we read or write stream. So, well, we done all the process that we need to do, and the only thing left behind is filling out the configuration settings. Let's fill out the Event Hub namespace name first. Head back to Azure. Let's go to the namespace that we created. Copy the namespace name. And the Event Hub name. Here. And also for the storage account name. Here as well. And for the containers, container name should be bronze. runs. And path, we haven't created any folder inside the container. But if we specify anything here, let's say patient flow, it automatically creates a folder inside the container and chooses that as path. So I just created patient flow as a folder name inside the container. I left out the connection string and also the storage account access key here, because we have a method to refer to the connection string without actually exposing the raw connection string in our code just for the security purposes. So we're going to do that. To do that, head back to Azure, click on search for key vaults, click on this icon, create a key vault, choose your resource group, key vault name, say hospital vault. Just it just act like a locker to our passwords or any of our personal information like credentials, access keys, connection strings. And the region should be India. I mean your region. Soft delete enabled days. This is defining the days that our key vault that are deleted to be in the recycle bin, basically. So if you delete a key vault, it stays in the recycle bin for 90 days now. Just hit review plus create. Create. After it is deployed, click on go to resource. You'll be landed on this page. Now here, we're going to save the connection string for the event hub and access key for the storage account as a secret in this key vault. For that, on the left pane, click on objects, expand objects, click on secrets. Here, it says the operation is not allowed by RPIC, the role assignment very recently changed. So in order to have access to create anything in the key vault, we ourselves need to assign ourselves as administrator for the key vault. For that, on the left pane, hit on access control IAM, click add role assignment, search for key vault and choose key vault administrator and switch to members, user group member service principal. Click select members, choose yourself as administrator for the key vault. So you'll get access to create secrets. Click review plus assign, review plus assign. If you switch to role assignments, you can see here, your username is assigned as key vault administrator now. Now head back to secrets again. Now click on generate and import. You'll land on this page. Now open a new tab and open Azure again. Login. We need the connection string of the storage event hub. Click on search for event hub. Now it is right here, our event hub namespace. On the left pane, like we did before, expand settings, click on shared access policies, root manager shared access. Copy the primary connection string, head back to the actual default tab. Here, paste the connection string in secret value and name your secret value as event hub connection. You can also specify the activation date and expiration date for that secret. I'm going to leave them blank right now. Click create. The secret is created. Now we need another secret to store the access key for the storage account. Click Generate and Import. Head back to the other tab. Click on search for the storage account that you created. Open that. On the left pane, click Expand Security plus Networking. Click on Access Keys. Here, save the key. Copy the key here and head back to the default tab. Copy the secret key in the secret value space. Should be able to see the secret key and name it storage connection. Storage connection. Create. We have both the connection strings and connection keys for storage and Event Hub that we need for the Databricks now. Now head back to Databricks and also open browser and search for URL to connect to create Databricks scope. You'll get the syntax for that. In the syntax, you just need to copy the string that is after hash symbol. Now head back to Databricks. In the link, take out everything that is after .NET, take that out and copy this hash string and hit run. Now you land on this page. You need to create a scope to access the vault from Databricks. So we are going to name the scope as Data Analytics Vault Scope and Azure Key Vault DNS name and resource ID. To get these details, head back to Azure Portal, Key Vault. On the left pane, expand settings, click on properties, copy vault URL right here, paste it in DNS name and go back to vault and copy the resource ID right here and paste it in the resource ID section. Now, before hit create, you copy the scope name. We need it later. Create. Hit OK. Now the scope name is added. Hit OK. Click on the workspace. Now, let's just paste the scope name here for now. There is a syntax to refer to this key vault. And the syntax goes like this. This is the syntax that we need to use. And before pasting the syntax, we need to take out the quotes too. It shouldn't be inside the quotes. Paste it. Here, replace the scope name with your scope name that you copied. Paste it here. And the key should be the secret name. For Event Hub, it is Event Hub connection. Oh, let me just copy this. Should be the key. And also do the same for storage account configuration. Take out the quotes and paste this. And for the key, it should be storage connection. And before running this code, you need to give access from the key vault from IAM, because we only gave access to ourselves as admin, but we never gave access to Databricks. So let's go ahead and add an assignment, add role assignment, key vault. This time, we're not going to give admin privileges to Databricks. We'll just give a basic privileges, which are key vault secrets user who can read the secrets. and click on members, click on select members, search for Azure Databricks. Select Azure Databricks, review plus assign. Now we give access to Databricks to read the access keys, but not write. The role is assigned now. Head back to Databricks. Now you will be able to retrieve the connection strings from this. And here we're not exposing the connection string in the code itself. We're referring it with this syntax, which makes our connection string more secure. Now we have all the configurations done, read stream, write stream, casting it to JSON strings, and everything is done. Now let's go ahead and run it. Run the code. Before running the code, we need to connect to the cluster. And our cluster is deactivated. Of course, I just said 10 minutes. We need to activate that again. Head back to compute, hit start. Now the compute is active, it started. Let's head back to the notebook. Now on the right side, click on connect to the cluster that we created. And I just found a few errors in our code. I just pasted the namespace name. We're supposed to paste namespace host name. So let's head back to Event Hub namespace. Here on the overview panel, we need to copy the namespace host name and paste that here. And also here should be raw JSON. That's it. Now let's run it. Click allow. Now it started reading the stream and writing it. We can see the jobs executing here and the stream in this chart. And to see how much of data is actually inside the bronze table now, we can create another code block to display and say display of Spark read dot format of delta dot load bronze path. Like as we use print in Python, we use display in PySpark. So display that, I spelled it wrong, should be display. Now we'll see the records that are already inserted into bronze table. Right now we inserted 99. Let's make sure, let's head back to Azure, storage accounts, our storage account, containers, bronze, the folder that we created, patient flow, and we can see a lot of Parquet files that are getting inserted into bronze table. That confirms the data is now ingested into bronze. Okay. Now we're done with the bronze tier table. Now we need to pull the data out and clean it and assign a schema and pass it. And then we need to push that into the silver table. To do that, we're going to create a new notebook. New notebook. name it 02 as a second step of the data processing, silver, clean data. Well, the steps involved in silver transformation code will be getting connection to the storage account, defining the bronze path and silver path. Bronze path to read the data from, silver path to write the data to. And then we define a schema and we parse the JSON strings that we pull out from the bronze path, and we parse it into an actual data frame. Because JSON string only saves the data as strings, it doesn't save the data type. So we parse it into an actual data frame. And then we clean it, and we add something to make it schema evolution friendly. And then we write it to the silver path. That's it. That's basically it. So let's start with importing the modules first from PySpark.sql.types. We need types to define the types in schema. Import all from types and also from sql.PySpark.functions. Import all. Here we need the configuration again. Let's get that configuration from bronze path, the bronze transformation code. Paste it here. We got the configuration for the storage account. We need to specify the paths now. We also get that syntax from bronze transformation code and paste it here for the bronze path, and another one for the silver path. Rename it to silver path, and here this should be silver. We have the path specified. Now we need to read the data from the stream. For that, we're going to keep a heading. Read from bronze. Say bronze df equals spark.readStream. Format, of course, the format should be delta. Load from bronze path. Read the stream that is in delta format from bronze path. Now let's define the schema to parse it, to parse the incoming JSON strings into a data frame. So let's define schema first. Define schema. Let's name it schema. Schema equals struct type struct field of ID. I think our first record name is patient ID, and that should be string type, string data type. Comma, struct field patient ID, comma string type. Now let's just copy paste it for the rest of the columns that we have. We have Excluding the patient ID, we have 1, 2, 3, 4, 5, 6, 7. 7 more columns. So we're going to copy paste this 7 more times. And take out the comma for the last one. And here we're going to copy paste these column names. Gender is also string type. Age is integer type. Let's change it to integer. Integer type. And then department is also string type. Admission time is also string type. Bed ID should be integer. Integer. Hospital ID. Here we define hospital ID should be integer type. Here we defined admission time and discharge time as string types because there is no timestamp type in the PySpark. So we define it with the string type here and we convert it to timestamp type later on. Now we define the schema. We're going to parse it now. Pass it to data frame. Let's name it parsed df equals bronze df dot with column data from JSON of call of raw JSON comma schema, the schema that we defined, dot select of data dot star. So the data dot star selects each and every column inside the schema and separates them as a data frame. And with this, we parse the data into a data frame, into an actual data frame, and we assign that parsed data to this variable named parsedDF. Now let's convert the data types of admission type and discharge time into actual timestamp data type. To do that, let's name it convert type to timestamp. To convert a timestamp, we name it clean df equals parsed df dot with column of admission time comma to timestamp to timestamp. of admission time. Same for the discharge time too. Just copy, paste it, and here we need to change it to clean df dot with column discharge time. So let's switch it from admission time to discharge time. And here as well. Now we converted the string admission time type to actual timestamp. Now let's head to the cleaning part, the actual cleaning part. We need to clean the admission times that are in future. So let's replace the future admission times to the present time. And also for the ages that are over 100, let's replace them with a random age limit from 1 to 91. So to do that, first let's deal with the invalid admission times. Clean df equals clean df dot with column of admission time when is null is greater than current timestamp comma current timestamp dot otherwise column of admission time. So here we are checking if the admission time is null or if it is more than the current time, which is future time, and replacing that with the current timestamp. Otherwise, we're just leaving it the actual admission time. So that is handled. Now let's also handle the invalid ages. Handle invalid age. Clean df equals clean df with column age is greater than 100, comma, floor of random of asterisk times +1 dot cast of int dot otherwise call of age. So here we're checking if the age is more than 100. If it is, then we are just picking up a random age from 1 to 91. Here the random of generates a decimal number between 0 to 100, and then we are multiplying that with 90, and then we're adding that with 1 just to avoid the null values. No, not null values. Just in case if the random generates a 0, we're going to add 1 for that and cast into integer. So we handle the age, invalid age. Now for the schema evolution, let's create a list first, saying expected columns equals list of patient ID, gender, age, department, admission time, discharge time, bed ID, hospital ID. And say let's do a for loop for column name not in no in for column name in expected calls, and for every column name in the expected columns, let's do if call name not in clean df dot columns in df equals clean df dot width column of call name comma lit of none. Well, this checks if the clean df has every column that is inside this expected columns list. If there isn't any column in the clean df, it creates a column with column name that is missing, and it assigns the value as none, which is the null value. So we do this for the schema evolution handling. And also, when we write the stream, to make it schema evolution friendly, when we write the stream with clean df dot write stream dot format of delta dot output mode append we add another option to make it schema evolution friendly, saying it should be a merge schema. Whenever the schema changes, the pipeline shouldn't break. It should adopt to the new schema with the new column that is added. And this option offers that function merge schema comma true, and then dot option checkpoint location checkpoint location comma to for the folder we're going to use silver path plus underscore checkpoint dot start of silver path to start writing into the silver path. So everything is same for the write stream like we used in the bronze transformation code, but we added another option saying merge schema to make it schema evolution friendly. If the schema changes with a new column, it gets added to a new column, or the schema is changed, the entire pipeline, the data pipeline won't break. It will adopt to the new schema. And the old data that is already stored in the silver table without that new column that is added will be assigned with null values. That is what actually happening here. Let's do a heading. Write to silver table. Before running the code, let's just ask ChatGPT if there is any syntax errors in this code. Say, will it work? Okay. Firstly, I made a mistake at the imports. Should be PySpark.sql dot function, and then otherwise placement at admission time. Right here, this otherwise. Should be placed after this right here, and type is unexpected column. I spelled it wrong. Okay, I spelled the patient ID wrong here. Supposed to be T. and checkpoint option fix. Oh, it must be a string. Okay. Here the checkpoint must be a string, and that's it. This should work now. And by the way, I want to let you guys know I just stopped the stream. I'm not running the code anymore because I already have more than 1800 records that are stored in the bronze. I think that's enough for our project. So I stopped the stream. Oh, because we already have 1856 records that are already stored in the bronze path. I'm going to stop this as well. Now start silver. Oh, I need to connect to the cluster. Oh, it automatically connects. Now it runs the code. Or should be functions. Okay. Now the stream started. Let's see. That's the job 1829. Now let's see how many records are getting stored in the silver path. For that, let's create another code block. Paste that display and replace this bronze with silver. Yep. The records are getting pasted to the silver path. Let's confirm it, going back to storage account, containers, silver container, patient flow. You can see all the checkpoints that are listed here. I mean the records that are listed here. So the data is stored in silver now. Now our next step is to transform this data and split the tables into two dimension and one fact for the star schema, and also make it SCD2 friendly. So let's create a new notebook, name it 03 gold transform. And also we have 1856 records in the bronze. Let's see if all the records are already ingested into silver. If it did, we don't need to run that computer anymore. So we already got all the records that are in the bronze pasted in silver too. So we can stop this. You see, unless we interrupt the stream, this doesn't end. It loops over and over again because we are using write stream and read stream method here. But unlike the silver and bronze, we're going to use a read in gold stream. Let's see how it works. Now for the gold transformation code, unfortunately, I cannot write the whole code line by line because it is a very humongous code. Even if I write it, it takes forever to debug the errors because I at least get 100 errors for this code because it's so big. So, and I want to make this video as short as possible. With that being said, I already have the code with me in the notepad. I'm going to copy paste it line by line and explain what actually happening in that code. So let's go ahead and
copy paste this. These are the imports that we're going to use. And now we have, for the configuration, we're going to copy the configuration from Silver transformation code. Oh shit. And then the paths. The Silver path, we need to change the storage account with our storage account name here. And silver, gold, patient dimension flow. So here, silver path is the path where we read the data from, and gold dimension path is the path where we write the dimension table for the patient, and gold dimension department path is the path where we write the dimensional department table, and the gold fact is the path where we write the fact table. So we have 4 paths defined here. And then we read the data. Like I said, unlike silver and bronze, we use read here, not read stream, because we need to read the whole data set for every single operation to get the old data too, to compare the new record with the old records and implement the SCD tool. So we need to use read here. And we have this code block. This code block helps us to choose the latest admission time and remove the old admission time from the data and assign that to this silver df variable. And from here, the actual patient dimension table creation starts. So a few more space there. We just copy paste it. We created another variable with selecting only patient ID, gender, age, which are the demographic data of patient, and also effective from, to track the status of that particular record. And we use this to check if there is already a data table exist in the gold dimension path in the storage account. If there is, it leaves. If there isn't, and this code is running for the first time, it will create a delta table with the data, including the columns with surrogate key effective to, which is by default assigned to null value, and is current, which by default assigned to true, and return to the gold dimension patient table. After that, we assign the table that is in the gold dimension patient to target patient, which is the historic data, and incoming patient variable stores the latest data. And after that, we create a new column that says hash for incoming patient and target hash for target patient, which stores a unique string that is generated by the combination of gender and age. We use a method SHA, which is string hashing. I'm not sure about the full form of it. SHA to, let's ask ChatGPT for that. SHA to hashing. It's a hashing methodology. I'm not sure about the full form. So secure hashing algorithm. So we use secure hashing algorithm to create a unique 256-bit string for every unique gender and age combination, so that we can compare the latest data demographic with the past data demographic. Now if we create the hashes and then we copy and paste it, and we create views for each of the data frames, and we use this SQL code block to compare these two data frames and pull out the records that are having a new hash strings. So we use the logic to compare them and say the target hash should not be equal to the incoming hash. So we compare them to get the records that have unique and different age or gender for that particular patient. We'll get that records and we assign that to changes df variable. And after that, we use this to pull out the surrogate keys of that particular records with new changed gender or age, and assign that surrogate keys to changed keys. This is I forgot the we use as a function expression to pull out the surrogate keys. And then we have if keys. We use if conditions. If there is any keys at all present in the change keys, then this executes and changes every status of the old records to false and assign the timestamp as current timestamp. And then we have this particular block, and here at the end we're going to combine all of that, including the old records and the new records. No, only the new records, and create the columns surrogate key and effective to is current, by default assigning to true, and this new column will be appended to the old dataset in the goal dimension patient table. With that, we created the goal dimension patient. We're done with that. Now we head to creating the department dimension table. So let's name it department dimension table creation. That's perfect. Separate that, and then we have this code block. Well, basically we just take department and hospital ID from the data set that is read from the silver path, and we assign a surrogate key for that table. We use this method to create an ID which starts from 0 to infinity. So monotonically increasing ID means starting the key from 0 to infinity. And here we override the data in the goal dimension department table. Now we created the dimensional table. Now let's head to the fact table. Give it some space and say create fact table. Now for the fact table, We read the data from the goal dimension department table and the data from goal dimension patient table. And for the patient, we filter out if the patient demographic data is currently active with this particular filter. And then we get the surrogate key, just the surrogate key. Surrogate key and patient ID and gender and age. And also same with the dimension department, but we don't use see if it is active because every dimension and department is active. And we use fact base to select the transactional data from the silver path that we read. And fact enriched. In this, we are going to join the dimensional path df along with the dimensional patient df to the fact table with patient equals to patient ID and department and hospital ID. And now we also will be creating few calculated columns. We're going to create length of stay hours by subtracting the discharge time with the admission time, and also is currently admitted is a boolean by checking the discharge time. If it is more than the current timestamp, we say true, or otherwise we say false. And we also create a column named event ingestion time to track the time when the record is ingested into the fact table. And lastly, we have this block. For the final fact table, we're only going to get the surrogate keys from the patient and dimension patient and department dimension tables, and we assign a new surrogate key for the fact ID and the transactional data: admission time, discharge time, admission date, length of stay hours, is currently admitted, bed ID, event ingestion time. With that, we got the final fact data frame. Now we will write that fact data frame into the goal fact table using override and write mode. So we are not using write stream and read stream. So this code should be executed manually, or we should schedule the execution. Every time a new data occurs, we need to execute ourselves unless we schedule it. It cannot be looped by itself. And at the end, we check how many records are inserted into goal dimension patient, in goal dimension department, and in goal fact. It will print it. And with that being said, let's run this. We shouldn't have any errors because we just copy pasted it. But let me check if I missed anything. Let's run the code now. Connect. Yep, it started running. The Spark jobs started running. Now we have to be able to see the data. copy that. Shows how many data, how many records getting inserted. So 1,856 records for the patient and 49 records for the department and 1,856 for fact rows. Here, let's just yep. This is for the patient dimension, and let's copy that. For the department, and finally, lastly, for the gold fact. Also, the calculated fields are assigned properly. Now, if you wonder if really the SCD2 works, let's show an example first. Let's insert a record, a dummy record inside it with the same patient but different age. To insert a record manually, let's create a variable saying manual JSON string and copy one of the record. Let's copy the first one. This record. Paste it here. And for this patient ID, let's switch the age to 80. 79 to 80. Now the old record that has 79 should go inactive and this record should get active. And also we need to change the admission date. Say 20. No, we can't say 20. Let's just say 19. But we can change the time here. Let's just change the time here to make this the latest data. Let's change it from 8:59 to 9:59. Leave the discharge time as it is and the rest as it is. Now manual tf equals spark dot create data frame manual JSON comma raw JSON has to be a string We have a problem here. Okay. This should be inside with a bracket. Should be enough. Manual div dot write to the stream and write to the table, write format delta dot mode of append dot save of bronze path Now we are manually inserting a record with the same patient ID but a different age and admission time. Path is not defined. Oh, my cluster restarted, so I need to run this code first. Now I can run this. Let me interrupt it first. That is stop. Let me run this just to make sure there is no new records inserted. No, there is no. So there is no new records inserted. Now let's run this again. So before I refresh this, before we have 1856 records. If we run this, it should turn into 1857 if our new record got inserted. So there it is. Our new record got successfully inserted into this. Now let's copy this patient ID so that we can use it in the filter later. And now we have to run the silver code to clean the new record and insert it into silver path. This should also turn to 1856, 1857. It is not done yet because the job is not done yet in the transformation code. Now we should find the new record inserted. 1857. So the new record got inserted into silver path. Now let's interrupt it and run the new record and run the goal transformation. There you go. It says a new patient added, but the fact rows remains the same, 1856. Let's check that with filtering out our new patient record. Our new patient record's patient ID is patient ID equals single quotes, and then paste. Oh shit. I need to copy the patient ID again. Paste it here. Run it. I'm going to filter just that patient ID. Now, here it changed the old record that says 79 as age is the status is changed to false, and the new record that says 80 is true, and it is effective to this current time. This is how we deal with SCD2, and it worked in our case. Now we are all set with the transformation. So data processing stage is finally done. Well, we're done with the bronze, silver, and gold tables, and we're done with the data processing. And this layer here, data factory, this is here because, like I said, bronze and silver loops over and over again. It is an infinite loop, but the gold, we have to execute manually every time we need the business ready data. Well, we can schedule the executions in the Databricks itself. Right here, when we click the schedule, and here if we say hours instead of days, and we specify 1, so this notebook executes for every 1 hour. But for a special cases, like if you want to execute the goal layer only if there are new records, there are n number of new records, like let's say you want to execute the goal transformation code only if there are 5 new records inserted into silver. We can do that using data factory. We can use if condition to check if the records that are inserted into silver are more than 5, only then the goal transformation code will be executed. We use data factory for that here to orchestrate it. Now let's head back to Azure portal, click on search for data factory, and hit create. Connect to our resource group and name it, let's name it Hospital Analytics DF, and your region, in my case Central India. Then hit review plus create. Hit create. Now hit go to resource. No, not hit. Click on the data factories. Your data factory. Click launch studio. Here, first on your left pane, click on manage. Go to linked services. Here, click on create linked service. Switch to Azure Key Vault. Continue. Now, before doing that, we need to do one more step. We need to head back to Azure, open our Key Vault, click on secrets. We need to add one more secret here. That is, head to Databricks, click on the profile picture on the top right, click on settings. In the left pane, click on developer options and click on access token. Generate a new token, name it something, generate. We get the token. This token will be visible to you only once, so you need to copy that and store it somewhere. In our case, we will be storing that in Azure Key Vault. And head back to Key Vault, generate a new secret, copy, paste the secret here, name it Databricks connection. Databricks connection, create, not now, head back to now, and then you head to IAM, access control. Here we need to give permission to the Databricks to access the key vault. And the privileges, just the read should be fine, which means we're going to use key vault secrets user and switch to members. Here click on managed identity, select members, select your subscription, and in managed identity choose the Data Factory version 2. Click on that, select review plus assign. Now we gave access to Data Factory for our key vault. Now head back to Data Factory, click on create linked service, switch to Azure, click on key vault, continue, name it hospital vault. Shouldn't contain any hyphens. Okay, hospital vault. From Azure subscription, your subscription, vault name, authentication method, system assigned, and click on text connection to see if the connection is set. Connection successful, and then click on create. And we need two more connections, two more linked services. So click new, click on Azure, and here switch to compute. You'll get the Azure Databricks on the top. Click on Azure Databricks, name it hospital Databricks, Azure subscription, workspace. For the cluster, I'm going to use the existing cluster that I already created in the Databricks workspace. And authentication type, we need to use access token, and we'll get the access token from the key vault that we created. Hospital vault, secret name, Databricks connection. Now it should get the connection, and we need to choose the existing cluster. I think I named it Hospital Analytics, hospital cluster. Click on text connection. The test is successful, so click create. We need one more connection for the storage account. So hit new, switch to Azure, Azure Data Lake Storage Gen 2, which is our storage. And here, name it storage hospital. Hospital storage would be nice. Hospital storage, authentication. Let's go with account key. Choose our subscription, account name, test connection, connection successful, create. We linked Key Vault, Databricks, and storage. Now head to, on the left pane, click on author, and here click on the plus icon, click on dataset. We're going to import the dataset first. Click on Azure, Azure Data Lake Gen 2, and the file format we stored the data in, Parquet. Linked services, hospital storage is our storage account. Name, let it be Parquet. And the file path, this should be silver. patient flow. Let me make sure that I spell it right. Go back to my storage account, containers, silver container, name of the patient flow folder. I'm going to paste it here. Patient flow, connection store, leave it as it is. Click OK. Now we connect it to the dataset. Now let's create a pipeline for this. Create pipeline. Here in the activity, search for metadata. Get it here. You can name it with a different one or leave it as it is. I'm going to leave it as it is, that's fine. And head to settings. Here, choose our dataset that we defined. In the field list, choose child items. And then that's it. And head back to the search and search for if condition. Drag it and drop it on the canvas. Connect get metadata to this if condition. Here, name it with a different condition name if you want to, or you can leave it. Head to activities. Here, we need to specify the expression here. So let me do that. At the rate grade or grade or equals. You know what? I have this saved somewhere in my folders. I'm going to paste it because I don't actually know how to write those expressions. So it's supposed to be this. Now this checks if the silver table has 5 new records added to that whenever it gets triggered. And if it is true, if there are 5 new records inserted into silver, then we have to add the Databricks notebook here. Then it will execute the notebook that we specified. And we need to define the notebook. Azure Databricks, Hospital Databricks, settings, notebook path. Under users, my mail ID, goal transform. So whenever the if condition satisfies the requirement, it executes. If it is true, it executes the goal transformation code that is in the Databricks notebook. If it is false, it just leaves. And at the end, we need to add a trigger to this. So click on add trigger, click new. Shows we need to create a new trigger name. Say goal trigger. Schedule it to refresh for every 5 minutes. For every 5 minutes, it checks if the silver table got added with a 5 or more new records. Only if that satisfies, then it runs the goal transformation code. Else, it just pass. So start trigger on creation. Click OK. Click OK. And now we need to publish the changes that we did. Publishing completed. Now this will trigger the goal notebook to execute whenever 5 new records get added to the silver table, or else it won't. So this is how we orchestrate it. Now let's give it to a test. If we just hit debug here, we can see if the flow is actually running. The pipeline is queued now. And here, after 50 seconds, every node in the pipeline is succeeded. To monitor the pipeline, we can head to the monitor panel here and see there is already an execution happen and it is succeeded, but it won't trigger the goal transformation code because the code we paused the simulator. So to check if it is actually working, we need to rerun the simulator and ingest some more records. For that, let me head back to my prompt window. Terminal and let me run that simulator again. Now run the bronze, run silver, and we don't need to run gold because that job is done by the data factory from our side. Now, after 5 minutes, it should rerun the pipeline and it should see more than 5 records are getting ingested into silver, and it should automatically run the gold transformation code for us. Now it is just waiting for the trigger to trigger it. Now the pipeline is started now. It is in progress. So now it checks if the silver table got any 5 new records inserted in it. It is still in progress. says it ran 29 seconds ago. Let's just refresh it. 29 seconds ago. And if we run this without the filter here, you have to see the records that are inserted. Oh, we need to run the notebook again. Okay. So let's just specify the goal path. And also the configuration. Now, there you go. The new records are added. We never ran the actual transformation code by ourselves, but the data factory ran and said the status successful, which means it ran the configuration, the transformation for us. Well, that confirms the data factory is working actually.
Creating a pipeline in the data factory and automating goal transformation is not just enough. We also have to alert, in case of the data pipeline failure, we have to alert the person who manages the pipeline. Like we mentioned in the client requirements right here, it says automate alerts in case of failures. So if the data pipeline fails, it needs to alert the one who manages it. To do that, we have to click on these three lines, head to monitor, click on alerts, create an alert rule, and here choose which tools to be monitored. In my case, I'm going to choose Data Factory and then click apply. And then after that, switch to condition, signal, failed pipeline run matrix, or if you want to choose some other, there are a lot of matrices that can be tried. In the search, you can just search for it. I'll choose failed pipeline run matrix, apply, and this is the alert logic. Here, aggregation type be total, the count, and the threshold. How many failures should be occur before the person get the alert? We say 1. Right after one failure occurs in the pipeline, the alert should be sent to the person to take a quick action. And then at the end, check for every 1 minute. Check failures for every 1 minute and loop back period 5 minutes. And now switch to actions. Here we specify which person and who should get the alert. We create the action group name it owner, display name, I'll name it myself. In the actions, we can type in an email ID manually, or we can choose mobile app notification, or we can choose someone from the subscription itself. I'm going to do that and choose owner, which is me. Save, and now details. Name your alert role. Let's name it fail alert. Review plus create, and hit create. Now, in case the data pipeline fails, the alert immediately message to the person who is responsible. In this case, the owner, me. And
the message will look more like this. It says, your Azure Monitor alert was triggered. Azure Monitor alert rule fail alert, which is our alert name, was triggered for Hospital Analytics DF, which is our data factory name. And it shows the time when it is triggered and the information about the alert, why it is failed, and everything. Now, we're good with the alerts too. Now let's head to the architecture. Well, we're almost done. We're done with all the steps: data source, data streaming, data processing. Now we need to pull the data that is business ready, that is stored in the gold. We need to create an SQL pool, which is our SQL warehouse in Synapse, and query this data so that we can connect to Power BI and create dashboards in it. For that, for our next step will be creating the Synapse workspace. Head back to Azure. In the search for Synapse workspace, Synapse Analytics. Click Create. Resource group, our resource group, workspace name, hospital. Synapse. And for the managed resource group, I'll name it MRG, Hospital Synapse. Region, Central India, from subscription. Like I said, we created a separate container in our storage account just for the Synapse workspace. Now we need to connect to that. Right here, account name, hospital storage, file system name, Synapse workspace is a container that we created. Security, create a pass, enter the password you like. And now review and create. Create. Just like the Databricks, creating a Synapse workspace will also take too long. After the workspace gets created, go to resource group. No, wait. Yeah, click on our Synapse workspace that we created. Now click on Open Synapse Studio. On the left pane, click on Data. Now click on Manage. So we need to create an SQL pool first, which acts like a warehouse. For that, hit New, dedicated SQL pool name. Let's say Hospital Pool. Performance. DW stands for Data Warehouse Units. And this performance level determines the bandwidth, actually. So we just go for the lowest bandwidth possible, which is DW100C. And for the additional settings, we're not going to change anything. Review plus create, create. And this SQL pool costs you $1.66 per hour. Wait until this gets deployed and the status changes to online. Once the status changes to online, let's refresh the tab first, reload, and head back to data. In the workspace, we'll see a section that says SQL database. When we extend it, we can find our SQL data pool here. And now right click on that, create new script, empty script, name the script if you want to. I'll just leave it SQL script 1 here. Now, firstly, we need to create a master key with a password. So let's create that first. Create the master key, encryption by password. I'm going to set password as temp @123 and a semicolon. Let's run this. That is successful, and now we need to create a scope, just like we created a scope in Databricks to access the keys from the key vault. We have to create a scope here to get access to the storage account. Let's start with the heading saying creating a scope. First, I create database scope credential, name it storage credential with identity equals managed identity. Managed identity and a semicolon at the end. Let's run this. That is executed. Now for our next step, we need to define the data source, which is our gold container in our storage account. So let's name it defining data source. Create external tables, external data source. With named gold data source with type equals Hadoop, location equals, for the location we need to use the syntax that we used for the silver path. The gold path should be here, not in the simulator. This one. Paste it here, and container name hospital storage, and storage account name is hospital storage, and container is gold. And hospital storage, and comma, credential equals the storage credential which we created. Just copy that. Now run this. Incorrect syntax, near location. Well, that's because we have to put a comma after every line. We forgot that. Okay, now run that again. Now it works. So we created the data source here. We defined the data source here. Now we define the format. Define format. That create external file format. Parquet file format. With format type equals Parquet semicolon at the end. Now let's run that. By the way, the SQL type we're using here is TSQL. And also all the codes and the commands that I'm going to use in this project and all the files related to this project will be uploaded into GitHub, and the link for that GitHub repository will be given in the description of this video. Okay, now we defined the data source, we defined the format, we created the scope. Now we need to create the tables and so that we can query the data from the storage account. Now let's create the external tables here. Let's say create tables. First one, patient dimension table. Okay. Create external table dbo.dim patient. And the columns that we are going to use retrieve in this table are patient ID, which is varchar type, varchar of, let's say, length of 50, comma, gender, varchar of 10, comma, effective from, which is varchar, should be date time 2, comma, I think I Okay, a semicolon here should be comma. And then the other columns, I forgot those names. In the goal table. We got patient ID, gender, forgot age. Forgot age, it should be right here. Age is int, comma. And then surrogate key effective to is current. Let's just copy that. Surrogate key should be big int. And effective to should be date time. And is current. With and now location is DIM patient. Yep, the location is DIM patient, comma. And data source gold data source should be gold data source, comma. File format is Parquet file format. That's it. Now we are creating a table dimension patient, and we're referencing the data from the storage account, which is stored in the folder dim_patient with gold data source as data source and file format as file format, Parquet file format, which we defined before. If we hit run, and refresh this, under external tables, we should be able to find the patient table. Under columns, we'll see all the columns that we defined here. Now let's create 2 more external tables. Just copy, paste it. Before that, let me put the heading, department, dimension, supposed to be S, right? And DIM patient, instead of DIM patient, we need DIM department. here, this is the important part. This is just the name that we specified for the external table, but this is the important part to actually connect to that storage space. Goal data source should be the goal data source Parquet file format. That's it. And we just need to change the columns here. The columns that are in the department or department, hospital ID, and surrogate key. So let's change that. We need surrogate key, so we'll leave it and we'll take out the rest. We just copy this. Department, which is in for char of 200, comma, hospital ID, which is integer, comma, and begin. This should work. Invalid syntax at line 43. Right, oh, we should take out the comma here. Now this should work. Okay, and let's create the fact table too. Let's copy, put heading, fact table, paste it, and for the path it should be fact patient flow instead of dimension department here. And let's also change this table name. And now we have to take everything down. Create it again. Let's open our Databricks to get the columns. Should be in bronze transform. Scroll to the bottom. So these are the columns that are in goal fact table. Let's refer them one after another. First one, patient SK. So first one is fact ID. We cannot copy that. Fact ID begin, and then patient SK, department SK, admission time, discharge time. Copy column name, begin, copy column name, paste it here, same begin, copy column name, date, time, 2. Column name, copy, date, time, 2. Admission date. Well, this is just date. It doesn't include time in it. And column name, length of stay hours is float because it's a decimal value. Is currently admitted. This should be bit because it's boolean, and bed ID should be int, and then event ingestion time should of course be date time 2. Now that should be it. We have the data source, location, and file format defined. Let's create this table as well. Okay, now refresh the SQL pool. Open external tables. We see all the tables, 2 dimension tables and 1 fact table. And we can, if we extend them, we will be able to see all the columns that we created. Now, just to make sure all the data is actually referred in this data warehouse, let's run a query first. Let's say select all from maybe fact patient flow. So this confirms the warehouse is successfully connected to the storage account, and it is ready to retrieve the data. And now our SQL pool is ready, and now it can query data from the gold storage and it acts like our data warehouse now. This is the best time to connect Power BI to the SQL pool that we created. So let's go ahead and open Power BI desktop. To connect with this Synapse, we need to click on Get Data from Other Resources. Click on Azure, choose Azure Synapse Analytics SQL. For the server name, we need to go back to Azure portal, and in your Synapse Workspace overview, search for dedicated SQL endpoint and copy the name. Because we created an dedicated SQL pool, we need to copy this endpoint URL. We copy that URL, paste it at the server name here. And for the data connectivity mode, we need to choose direct query, which allows the dashboards that you create to be real time. If you choose import, the data will be static. And then click OK. After authentication, we will be able to see our data SQL pool and the tables and the views that we created. For now, I only created the tables because I can create the views and the dashboard in this video. It makes the video lengthier, so I decided to do another video with just the analytics part in it and create views and the dashboards in that video. But for now, we will be completing all the data engineering part of this project. Okay. With that being said, we got all the tables that we created into the Power BI, and the columns are shown here. Well, let's take a look at the architecture again. Now we're done with all of it. Data source, data streaming, data processing, and warehouse. And we connected warehouse to the Power BI to create the dashboards. So we're done with most of the data engineering part, but we still need to add the codes that are the transformation codes, the bronze, silver, and gold transformation codes that we used in Databricks, and also the Synapse SQL queries that we use into our Git repository. That's the only thing left. So let's go ahead and open Git Bash. Before that, let's copy our codes and create .py files for them. Open notebook, don't save, take out all this, create a new notebook. First, let's go to the bronze raw data, copy, paste it here, save as, C drive, users, username, in our repository, inside Databricks notebook, let's name it, say, the same name, and the save type as all files, and at the end it should say .py, and save. And remember, GitHub won't allow you to commit the files that have credentials or personal information. So let's go ahead and take out all this stuff. And also for the storage account configuration, let's replace this with storage account name. Let's code this with storage account access key. Here too. Okay, I think that's fine. And here as well, we need to replace this one. I think that's it. Let's save this file and create a new notebook for silver. Copy, paste it. For the configuration, we copy the configuration from here. And the path, we'll copy that from here. That's it. Save it in the same folder and name it all files, and at the end .py. Save. In the same way, the goal transformation table, code here, and for the path, use the same syntax here to replace, and silver path, use this. Replace every path that we defined. And name it goal transform .py, files, all files, UTF-8. And also do the same thing for the queries that we used, the TSQL queries. We paste it, the password, replace it with the password. The path, same as this. And scope credential, and that's it. Password. Now save it and name it SQL Pool queries. All files, why not? No, I did a mistake. The queries doesn't belong here. Should be in the SQL Pool queries. Okay, now push these 3 files and SQL Pool queries into Git. To do that, open Git Bash, copy the path for Databricks notebooks, copy the whole path, paste it here. Now, first we need to say cd and then paste it. Oh well, it's supposed to be backslash. Now paste it. And git add dot git commit -l all Databricks notebooks. 3 files changed. So we added these 3 files. Now we need to hit now cd dot. It go backs one folder. Now we need to select cd SQL queries. paste it. And now git add our file name, paste. I think it's a txt file. So we do git add paste at the end dot txt. Now git commit -m SQL pool table creation queries. Now we need to push these commits into the actual GitHub. To do that, we need to type git push -u origin main. That is done. Now let's go check if the commits are actually added. Hospital patient flow analytics. We have Databricks notebooks and SQL queries.
And now we're done with the final step of the data engineering part of our project. And like I said, I will do a separate video for the data analytics part and I'll upload it to YouTube by next weekend. And I'll try to link that video in the outro screen of this video. And with that being said, I'll see you guys in the next video. Until then, adios.